Welcome DC circuit students. In this mini lecture we're going to use our multimeter and our solderless protoboard, a DC voltage source in the form of a 9-volt battery, and a couple of resistors to measure the current that flows through a series resistor circuit. We're going to use this as an opportunity to use our multimeter as a current measuring device. So most digital multimeters have several connections where we put our measurement leads, and if we're measuring resistance or voltage, we'll use the two over on the right. Common meaning ground, or the common point, which is where we typically put our negative measurement lead, and then you can see the V for voltage in red, meaning positive, or the ohm symbol. We also have a diode checker available if we're working with semiconductor devices. Over on the other side, we have red, indicating our positive measurement lead will go there. And we have two choices, a full scale or maximum of 400 milliamps or a full 10 amps. So these are the two connections in which we'll plug our positive measurement lead if we're going to make a current measurement. So we could calculate what our expected current is, and given that we're only using a nominal 9-volt source, we're probably not going to have very much, but it's always good practice if we haven't actually run through the calcs, use the larger full scale. You can see, I'll use my meter banana clip to point here. You can see the word fused. In this case, we have fuses that will limit the current flow, will open and interrupt the circuit. And you won't be able to use your meter, but you will have protected your meter from damage, and you just have to replace the fuse. So you have a fuse with greater ampacity in this case, which allows 10 amps to flow, and lesser in the 400, and a different measuring circuit that can handle more current in the case of the 10 amp. So we're gonna play it safe, and we're going to use the 10 amp. And to do so, we're going to come over and we're going to turn our meter on to our milliamps, and you can see it defaulted. Oop. Let's put this where you can see. It defaulted to AC. So I would get a very strange reading. So on this particular meter, I can toggle between AC and DC by hitting that button. So now we'll be measuring a DC current when I hook the meter up. So probably the most important thing to remember about using our multimeter to measure current is we must put the meter in series in the circuit. And so to do that, I'm going to start out with the source, and I'm going to make sure that my meter is in series by connecting the meter directly to the source. So I have my negative lead is going to go into my meter. So now current is flowing from my battery. Actually, it would be flowing from the conventional positive, but it's flowing through the meter, and is now going to be able to return to the circuit, or is going to feed the circuit. Then it will return to the battery via this other lead. Okay. So I can only see a little bit at a time and stay in focus. So basically now this lead of my meter is basically going to supply my circuit. So I'm going to go ahead and put that. I'll use a little bit shorter one there. So I'm going to build the same circuit that I did in my previous video. I'm going to make a series circuit with two resistors. So I'm going to take my current, my positive rail, I'm going to put it in row 59, and I'm going to put a couple of resistors in series. Straightening the leads a little to make sure they're not kinked. Okay, I don't have my meter available to do a continuity check because I have it arranged for current, and I don't want to restructure it for a resistance or voltage check for fear that I will accidentally place it in parallel, which I don't want to do. So I'm going to do just a quick check again. I'm going to start at my battery, the negative lead, going into, see if I can show this, negative lead going into the negative of my meter, flowing through the positive lead right there into my circuit. And from there, we're going to go through this resistor, through the other resistor, and then back out, and at that point I want to return it to the battery. So I have one connection of the battery left. It's a little bit of a tangle here. So I have what is a nominal 9-volt battery, and I have approximately 1500 ohms. So I don't have my calculator handy, but I could say that I have something on the order of 10 volts divided by 1500 ohms. So that would be 1 times 10 to the first volts divided by 1.5 times 10 to the third ohms. So I'd have 1 over 1.5 times 10 to the minus 2 amps, and 1 over 1.5 is about 2/3 times 10 to the minus 2 amps. So that's going to be in, so that gives me about 0.66 times 10 to the minus 2 amps, or about 6 milliamps. So that should be very safe to measure with my meter, and especially on that setting. So I could probably go to the other setting. So that was a quick aside of, if you don't have your calculator, you can use scientific notation. So we've plugged in, and as you can see, doesn't look like we're flowing much. So my first thought is, make sure we are totally connected. We are. So I think we can go to our more sensitive reading. And if that doesn't give us anything, then we reconfigure the meter and go checking. Aha! This is more like it. So we were able, with our quick calculation, we're able to assure ourselves that we're going to encounter currents that were well below our 400 milliamps. So we went to the more sensitive setting, and lo and behold, about 6.5 milliamps, which is pretty close to what we calculated. So our meter is in series. We are on the correct sensitivity setting to measure what we need, but not too sensitive for the currents flowing. And we've been able to measure a current that we would predict from Ohm's law, give or take. And that is also, if we went back and calculated our power dissipation over our two resistors with this current flowing, we'd find that we're well within their power dissipation rating. So we have a safe circuit. So we are directly measuring current rather than inferring it from Ohm's law in this case, and if we let this go long enough, we would see this begin to drop as the battery discharged, but it would take a while for this resistance. So that is it for a series circuit being measured, directly with our meter. The meter is in series with the rest of the circuit, and we're measuring with our DC setting milliamps on our sensitive range.